allowing me to do Zoom or something like that. So I've been on this one and I didn't know how to like send it on email.
No problem. No problem. So this is number 5. I'll write the answer and then we can talk about why this is the answer.
Mm-hmm.
So 3 squared equals 9. And it comes from the previous line. It's not just like, oh yeah, 3 times 3 is 9. It's that the 2 becomes the exponent, the 3 becomes the base, and the 9 goes to the other side of the equation.
Yeah.
So what I think I mentioned before is you want to have like a reference in your notes or just a mental reference where you always know how to move back and forth between these. And
Yeah.
I'm not sure if that's clear, but like I usually write log base b of x equals n, and then you can say that b to the n equals x, something like that.
Yeah.
Or you can make up your own, but that's a really good reference. It's just like where we say, okay, the square root of x is x to the 1/2, that kind of idea. So that's a simple reference. Okay, enough on that. 7 is log base 6 of 1 equals 0. This is a property. The property is log base b of 1 is always 0. So this right here, doesn't matter what it is, not important, but the 1 is. The 1 tells you that this is always 0. Maybe that doesn't make sense. The right side is always 0.
Yeah.
Okay, so I mean, there's no work. You just there's my answer. All right, 9. We did not cover this. I was avoiding doing these with you because they're very unclear. For this, oh, we're just rewriting it. I'm sorry, I didn't rewrite this one correctly. Sorry, this is 6 to the 0 equals 1. I'm sorry, I got sidetracked on what we're doing.
Oh, it's fine.
But that property is important. So this one's weird. It's 1/2 to the power of -4 equals 16. And you may not think that that's true. We could talk about why it is true, but you just have to rewrite it. You don't have to actually show that it works. So is that okay? Can we just leave it? I mean,
yeah,
okay.
That's good.
So 11, 13, and 15 are going the other direction. They're giving you the answer, and you have to go back and write it as log base 6 of 36 equals 2. This is usually the harder direction to go for students.
Yeah.
Does this match what you've been doing?
Yes.
Great. So number 13. I mean, it's awesome that you're able to do these on your own. I mean, that's really the key here of these lessons, is give you the confidence, the knowledge to be able to do this without any help. So log base 16 of 1 over 16 equals -1.
Yeah, that's what I got.
All right, 15. 125 to the 2/3 power equals 25. So it's log base 125 of 25 equals 2/3.
Yeah.
All right, so now we can move on to 17.
Yes.
All right, now these actually do require you to do a bit of work. A lot of these can be done in your calculator, but I guess the expectation is that you're going to have to do these by hand. So you have to remember that 81 can be written as 3 to the power of 4. It's also 9 squared. And that's probably the one you're more familiar with, but that doesn't help you because you need the 3 to match the base of the log base.
Yeah.
So it's log base 3 of 3 to the power of 4. So you're going to bring that 4 out in front, 4 times log 3 of 3. And this is a property now, log base b of b equals 1. It equals 1 because these match, the base and the thing you're taking the log of.
Right.
So this means that it's 4 times 1, which is just 4. And you could say, well, is it just always the exponent? It's like, well, yeah, it is. But if there's something out in front, then that affects it. So it's good to kind of work through the progression just in case there's a little extra wrinkle for it. All right, 19. Well, we just actually did one like this.
Yeah,
This one is log base 3 of 3. And since these match, this just equals 1. Because there's really a 1 up top. There, you can really,
right.
I don't know if you've seen this, but if you just pick your favorite number, there's a power of 1, you're multiplying by 1, you're dividing by 1, things like that. There's actually a
Yeah.
lot of ways you can rewrite a number.
Yeah.
All right, 21. All right, finally one with I think a bit of work here. Log base 5, 1 over 625. I wanted to ask you, what did you try here, if I may know? Because there's many ways to go about doing this one.
So I think what I did, I think I just took 625, like 5 to the square root of 5,
So 5 to the
Or-
power
or
of,
5 to the power of, yeah.
I think it's 4 though.
It's -4. Yeah, that's what I got. I think I
Okay.
worded that wrong though.
Yeah. Now 1 over 625 is 1 over 5 to the 4, and then to bring the 5 up, you change the exponent from a positive to a negative, so it
Right.
switches
Yeah.
sign. All of that being said, so that you can replace 1 over 625 with 5 to the -4. And just like the first problem we did 17, you can bring that exponent out in front, -4 log base 5 of 5. And then that part right there is 1. So it's -4 times 1, -4.
Right. Yeah, that's what I got.
Fantastic. All right, 23. Log base 4 of 0.25. So the what I would do here is tell you to rewrite 0.25 as a fraction. And now you can treat it like the previous problem. The base here is important. The fact that it's a 4. So maybe you haven't done this in a while, but it's really 4 to the 1. So you can bring it up as 4 to the -1.
Yeah.
Which I think is a little awkward to hey, we don't walk you don't walk around telling someone, oh, it's 0.25, oh, it's 4 to the -1. They would really find that confusing. But in math, apparently it's okay. These are just games they're playing just to see if you know how to manipulate the numbers.
Yeah.
So bring that exponent out in front, -1 times log base 4 of 4. That part is 1. -1 times 1 is -1.
Yeah.
All right, so it looks like we got to do number 25. You actually occasionally see these types of problems on social media from the math people out there. They're pretty hard to do without a calculator.
Yeah, I'm pretty sure I did this. I definitely did this one with a calculator.
It is possible to do by hand. It just is really hard. Did you have any issues with how to type this in your calculator? Do you need help with that?
No, we learned how to do that, so we
Okay.
can skip this one if you want.
Sounds good. So your dad, and I talked to your dad briefly. I mean, I know he's not a math guy, but logarithms were used by people kind of in like 1 or 2 generations away from you, rather than using other numbers. And they actually used to look these up in tables. Your dad might have had a class. My dad had a class where he had to actually look these up in a table, not a calculator. So it was very, very different time. Believe it or
Yeah.
not. So, all right. So it looks like we're up to 27. I don't see 27. Oh, I see part of it. I see log 6. There we go. And I think this just says to do it in your calculator. Is that right?
Yeah,
Now,
so these ones are easy too.
Now, if no base is given, that means it's a 10.
Right.
And really no way to go wrong except to type these in wrong. 29 is the natural log of 1/3. ln is in your second, usually second e. And
Yeah,
then 31 is 3 natural log of 0.5, like that. Just be careful with your rounding on this. They usually give you like a calculator and a no calculator part in this test. Is that something you've experienced in this class where you have part with no calculator, part with it?
I think we've always been allowed to use our calculators for pretty much everything in our
Okay.
class.
Okay, that's good to know, because that I would assume you'll get some number of problems like these where you just have to type it in, see what you get.
Mhm. Yeah,
Okay, so you can see we're moving pretty quickly. Maybe there's a bit more to this. Yeah, okay, 43. Yeah, 43 through 45. A lot more here going on. All right.
yeah,
All right. So let's look at 43. Y equals 0.3 to the power of x. Okay, so there's a recipe for finding the inverse. And the first step is to switch x and y. So you got x equals 0.3 to the power of y. The second step is to solve for y, and that's probably the most difficult one for most students here.
yeah.
Now there's a couple ways you could do this actually. Did you use natural logarithm?
I used like log instead of ln.
Okay, so both are acceptable. I'll just put this off to the side. So you can take the log base 0.3 x equals log base 0.3 of y, like that. And then on the right, the y comes out in front. I'll just show this one with all the steps, but then the others we may not. So this right here is 1. So it's really just y equals log base 0.3 times x. And then it's kind of a step, but it's really just rewriting it. You say f inverse of x instead of y. It's kind of the final step, but it's not really a step. You're just rewriting this because it did ask for the inverse.
Yeah.
Although it didn't give you a function to start, but so this is everything. So did you get this? I guess is probably the more. Is this your result?
I
Fantastic.
did get that.
Fantastic. All right, I'm going to do 51 next because it's the most like 43. So in 51, you have y equals 5 to the x minus 9. So step 1, you're going to switch x and y. X equals 5 to the y minus 9. And then second step here is to solve for x. Solve for y, sorry. Y, not x. Okay. So the first thing, we're going to add 9 to both sides. X plus 9 equals 5 to the y. And you can use the ln or log base 5. If you're going to use log base 5, probably get to put that in parentheses. So it's log base 5 of x plus 9 equals log base 5 of 5 to the y. And by now you probably realize the right side is y. So there's your inverse.
Yeah.
Sorry, I put this way off. Log base 5 of x plus 9, like that. Any questions before we go the other direction?
No, I think we're good.
Okay. Okay. 45. So do you think something has changed for you? Like, is it more clear what's going on in class, or are you having more time to look at this stuff? Like, it does seem like you've already got this down.
Yeah, I don't know, maybe this topic like came easier to me. He also explained it in a way that I understood, and we got a lot of time to work on it in class. So
Do you have block periods where you get a little more time some days to work on stuff?
no, our school is like we have the same 6 classes every day for the exact same amount of time, unless we have like a half day or like finals day where we have 3 classes into like one day.
Okay. So there's advantages, disadvantages of that, right? Seeing your math teacher every day versus, a little break in between.
Right.
So that's good. That's really good. Okay, yeah. So here you got kind of the same steps. You switch X and Y. And you're just going backwards now. So to undo the log, you use this 2 here as a base. So it's 2 to the X equals 2 to the log base 2 of Y. And on the right, the Y cancels and you get 2 to the X. Now, believe it or not, I mean, what we're doing is like what we were doing in those first few questions, like the questions, I don't know, 5, 7, and 9, or the next grouping where you're just rewriting it from one to the other. It's actually the same thing as this. But that is your answer, 2 to the X.
Yeah.
So what I think the instructor is trying to get you to see here is that your like the inverses of each other is an exponential or a log. That is what's trying to be explained here.
Right.
A log inverse is an exponential, and an exponential inverse is a log.
Yeah.
Okay. 47. 47 is next.
Yes. Yeah.
All right, so we got y equals natural log x minus 1. So we're gonna switch x and y, and we're gonna solve for y. So we haven't done this yet, but to undo ln, you use e. Like that, and e to the natural log of, let's just say there's an x up here, that this always becomes x, or whatever's inside.
Yeah.
So the right side just becomes the y minus 1.
Mm-hmm.
And just add 1 to both sides to finish up solving for y.
Right.
And that is your inverse there.
Yeah, that's what I got.
Fantastic. All right, 49. Y equals e to the 3x. Again, you switch x and y. Solve for y. So to undo e, use ln. So again, kind of another property there. Natural log of e to the x becomes x, or whatever's in the exponent. So if it was like 10x or 50x minus 3 plus 12, that's what it results in. So the right hand side becomes 3y. And then you divide both sides by 3. So y equals natural log of x divided by 3.
Okay, I'm writing this one down because I didn't do this one. Okay. So then that would just be your answer, right?
That's it, yeah.
All right.
So you probably didn't know if it would go this fast, but we have quite a bit of time left to do some other things.
Yeah. We can do like, if you have any other examples of those, or we can do stuff from.
Why don't I give you a couple of each to solve, unless you have a new topic you'd like us to cover?
No, yeah, that sounds good.
All right, so let me look at the assignment again and just throw some at you to see, because the hardest part is when you don't get. Wait a second here. Did you not have any from 35, 37, 39?
Let me see what I sent.
I don't think he said to do those, but I guess probably could look at some of those. 35, 37, 39.
35. Oh yeah, I do have. Wait, 35. Wait, I can't even find that one. Oh,
They're not really different. They lead into the next grouping problems that we did. I'm just surprised that, I don't know, I just thought you would
oh
have
yeah,
some.
I don't think we've learned that yet.
Okay. Let me give you a few problems here to look at here. So let's do a rewrite here.
Okay.
Rewrite a to the x equals 4. And you're rewriting it in log notation. I've made this one intentionally hard just to see if there is full understanding. So if you don't get it, we'll do some easier ones. Come back to it.
So rewrite this into log form.
Yes.
Okay. So it would be log base a to the 4th equals x.
If you wrote this, what you said was correct, but if you wrote this, that's also correct.
Yeah, is that different from what I said?
You said, and I'm not trying to be picking on you. You said log base a to the 4th.
Okay.
And so that could be interpreted like this, which is really
Yeah.
weird, but like you want to say of for what that
4.
part. I mean, it's not an
Okay.
oral exam, it's not like you're going to stand up in front of the class and have to
No,
use the word in a sentence or something
yeah.
strange, but it's math is kind of a language in some ways. All right, good. Let me give you another one here to let's go the other direction. I'll clear the screen here. Log 91 of z equals x, like that.
Okay. So it would be 91 to the x equals z.
Yes. Very good. Okay, let me find another one here. Actually, let me just mute for 30 seconds. I'll be right back.
Okay.
Okay, I'm back. Sorry about that. There's some noise in the background that's taken care of.
Oh, no, don't worry.
All right, let's go to an evaluate. Yeah, let's do some evaluate. These are important to be able to do. All right, log base 2 of 1 over 32. Let me give that one a try, please.
So would it be 2? I don't know if I've ever done this kind of one before. So 2 to the oh.
What is 32 as a number to an exponent? And I think you're about to say 2 to what power gets you to 32?
it would be 5, right?
5, yeah. Now, when you bring the exponent up, it changes sign.
Oh, right. So it's to the -5.
Yes.
Okay.
So this is really 2 to the -5. How do you simplify it from here?
So it'd be log 2 to the 1/32.
Well, that's the question, but it reduces to the line below it.
And then,
So what you're allowed to do is bring that exponent out in front. So it becomes -5 log base 2 of 2. And that is 1. So it's -5 times 1.
oh, okay.
I want to give you another one like this, so copy down what you need to. I can also scroll up, but I would encourage you to get this down in your notes.
Yeah, just one more second. Okay.
Got it?
Yeah.
All right. So let's go log base 3 1/81.
Okay, so it would be 3 to the -4.
That's
or
right.
of -4.
Well, this time it is 3 to the -4. 1/81 is 1/3 to the 4, which is 3 to the -4. But in terms of how you say it, it's log base 3
right.
of 3 to the -4.
Right, yeah.
And this is not me. This isn't like, hey, Matthew's really picky. This is like how it's presented in these textbooks and what's like accepted. Like, I mean, I don't really care. I mean, this is not
No,
useful,
yeah.
but this is what they expect. And so like you ever have someone come into your friend group and they don't kind of know the words you use, or parent tries to talk to you about something that
Yeah.
it's awkward. So it's good if you know the language for it. So
Yeah.
this comes out in front. What's the final result here for this one?
So it'd be -4 log and then base 3 to the 3rd. Or of
Okay.
3. Yeah.
Would you do anything else from here?
No.
So let's go back and look at the previous problem. See how our previous problem, we got it down to a single number.
Oh, right.
So whenever you have the log base b of b, it becomes 1. So the whole reason you're bringing that exponent out in front is because this right side reduces.
Okay.
So your final answer is just -4. Is that okay?
Yes.
All right, you ready to do one more?
Yes.
Log base 4 of 1/64.
So it would be 4 to the -3.
Yes. Give me the final answer. Yeah, pretend like there's only a box here and you can only put a number in. Just give me that final answer
So it'd be 1.
for the whole thing.
Okay. -3, and then log 4 to the 3rd.
So here's what I guess, so this part is 1/64. That's 4 to the -3. Did you get that far to
Yeah.
writing that? Okay, now what do you do with the -3?
You put it out in front.
Now notice the 4 stays, that 4 stays there, and it's the
Oh,
-3 that comes out in front.
right, yeah, to the fourth, that's why. Okay.
So again, kind of tell me what goes in this box up here for your final answer.
So then you put it over -3.
Just -3.
Yeah.
Okay, let me try to illustrate this with with a different kind of example. Log base 2, 2 to the 5th, minus log base 3, 3 to the 4th, minus log base b, b to the power of 1, plus log base pi of pi to the power of 8. So here's what we're going to do for each of these. We're going to use that exponent rule. We're going to bring the exponent for each one out in front.
Okay.
So it's 5 times log base 2 of 2 minus 4 log base 3 of 3 minus 1 times log base b of b plus 8 log base pi of pi. And what you should notice about every single one of these is that the base is the same as the thing you're taking the log of. Is that
Okay.
that
Yeah.
clear?
Yeah.
Now, the reason that's so important is that you can reduce that. What do each of these reduce to?
1.
1. So it's 5 times 1 minus 4 times 1 minus 1 times 1 plus 8 times 1. Now, I don't think your instructor is going to be something weird like pi or something like that, but you do need to be like, oh yeah, this is what it reduces to.
Yeah.
Okay, so let me give you an easier numerical example to try and see if you've got it. Is that okay?
Yes.
Log base 2 of 16 minus log base 2 of 1/4.
So the first one would be 4.
That's right. It becomes log base 2, 2 to the 4th, which just means 4 times log base 2 of 2. So it's just 4.
And then minus, that would be -2 log base, or -2 log 2.
Like that?
Yeah, or to the 1/4. It's 1/4, not 2.
Well, then, okay, so then you can't, I think you're doing too much then in one step. Like 1/4 is 1/2 squared, which is 2 to the -2.
Mm-hmm.
So maybe you meant this. Yeah, obviously I can't see what you're writing. Did you mean this?
No, I think I just messed it up. So I think so it'd be -2 log 2 to the
Of 2.
of 2.
Yeah, I know it looks like this middle 2 here is an exponent of this base, but it's really supposed to be in parentheses. And that's maybe why
Yeah.
I don't know if that even helps, but these two negatives make a positive. And then you have this 2 times log base 2 of 2, and that becomes 1.
So then it would be 4 plus 2, which is
Yes.
6.
Good. Let's try one more. One more here. All right, so let's say it's log base 5 of 1/25 minus log 5 of 125. Something like this here.
So the first one would be -2.
Yes, I mean, the whole thing is -2.
Yeah.
Okay, that's what you mean, I agree.
And then the second one should just be +2.
It's 125 though.
Oh, 125.
Yes,
So it would be 3.
yes.
It's the -5, yeah.
Okay, good. All right, let's move on to another topic here. All right, so the next one, I guess, for just some inverse problems. So determine the inverse for, let's go, y equals 3 to the power of x. So I guess give this one a try. This is very much like 43 in your book, or even 51. You want to give that a try, or do you need a refresher on this?
I think, let me see. Yeah, I can. So yeah, I can do that one.
Okay.
So then it would just be log base 3 of x equals y.
Yes.
Or y equals.
Or, yeah, the inverse. It's exactly what you said. It's log base 3 of x. Yeah.
Okay.
So that's pretty clear. I guess this ln stuff probably still isn't clear. So I mean, here's a problem that you might see something like this. It would say to solve for x, and you might get something like this, like 5 equals e to the x. So to undo e, you use the natural log on both sides. And it undoes the e, but it's because the x actually comes out in front. So this is x times the natural log of e, and those undo each other.
Right.
So this is 1. It's kind of like the problems we were doing. So it ends up being x equals the natural log of 5, like that. So you can make these problems a little more complicated. So, okay, let's say it's 10 equals e to the 2x. All right, so you take the natural log of both sides, like that. So on the right hand side, it's that exponent comes out in front. And so it's 2x times 1, because the natural log of e is 1. And then there's just a little more work to do. You have to divide both sides by 2. So what's uncomfortable is that, like, you have to treat natural log of 10 like it's a number, even though it's got an ln. It's still a number. It's just not a nice number. So you have x equals the natural log of 10 over 2.
Yeah.
All right, so can I give you a couple to solve here of these?
Can you actually do one more of
Sure.
that kind?
Sure, I'll make them a little more difficult each time. So it's 3 equals e to the 4x minus 5. Something like this. You'll probably see this in class soon-ish. So you use ln to undo the e, like this. So on the right side, it just becomes what's in the exponent. And
Okay.
now you just treat that natural log of 3 as if it was just as if it's a number, and you're solving for x. This is not the inverse, by the way. I think you got that down. This is just solving equations, which you're going to see. So you add 5 to both sides, and you just write it next to the natural log of 3. You can't combine them. It's in parentheses. It's different than the 5. Equals the 4x, and then you divide by 4 here. So you have 5, or actually you can just leave it like that. That's probably okay.
Okay. Yeah, I feel like those ones are like a little bit more difficult than all of the other ones.
Fair enough. Yeah, I mean but you'll probably see these here in the next day or two in your class. So let's have you try one here. Let's say it's a 6 equals e to the x. I want you to solve for x, please.
Okay. So once you turn the e to the natural log.
So I'm hoping you wrote this. Is that possible?
Yeah.
Okay.
Yeah.
So the idea is that the right side becomes just the x, but the reason is because you actually bring the x out in front, and the natural log of e is 1.
Mm-hmm.
So the natural log of 6 is just x, or x is the natural log of 6.
And that's just the final answer.
Yeah, and it doesn't feel right because you're like, well, I'm used to it being a nice number, something that works out a little more. Because what is the natural log of 6? It's if you put it in your calculator, you get something, but it doesn't really mean anything to you.
Yeah.
Okay, let me have you try another one here. Let's say it's 4 equals e to the 2x. I'm gonna try solving this one for x.
So would it be, oh, actually, wait. ln to, or ln of 4 over 2 equals x?
Yes.
Okay.
So just to be clear, the 2 or divided by 2 is outside of it. So it's almost better to write it this way, where the 1/2 is out in front.
Yeah.
All right, let's try one more here. Let's go 5 equals e to the 3x minus 1. Again, solve for x.
So ln, and then do you add 5 and 1 or do you keep it of 5 plus 1?
Well, let's look at what the right-hand side becomes. The right-hand side becomes 3x minus 1. Like whatever you have in the exponent after you take the natural log, that's what's left over. Do you see that? Just the exponent?
Yeah.
So to answer your question, you're going to add 1 to both sides, but you're not adding it to the natural log. Like it's 1 plus the natural log of 5.
Yeah.
You can't combine it. It's not natural log of 6. It's awkward. It's just not, they're two separate things.
Right.
Okay, now we're going to divide by 3. But you're dividing everything by 3.
Yeah.
So it's 1 plus natural log of 5 divided by 3. Your instructor expects this answer. They expect something that doesn't look, ideal.
Yeah, okay, that's what I got.
Fantastic. Well, that does take us to the end of our lesson for today. If you need another lesson before your test this week, please schedule. Be happy to help.
Yeah, I think I'm actually gonna do that right now. I think I was gonna do it Wednesday probably.
Sounds good. I'll be
Thursday,
looking forward to
maybe.
helping you, and hope you have a great rest of your night.
Thank you, you too.
All right, bye now.
Bye.